Hi, I'm Tim from Scoop. Mikrotik has powerful methods for managing packet flows using queues and firewall mangle. Although this works exceptionally well and will always have its place in RouterOS, this method requires a lot of configuration and know-how to achieve decent results. For those looking for a more straightforward solution, a new queue type is available in RouterOS version 7, which significantly reduces time spent on configuration with impressive results. Codel is a technique that was designed to combat buffer delays known as buffer bloat, introduced into queues with high amounts of traffic. Reducing these delays significantly improves latency and, by extension, a better overall QoS experience. Fair queuing with controlled delay uses a randomly determined model to classify incoming packets into different flows. This is used to provide a fair share of bandwidth to all the flows using the queue. Each flow is then managed using Codel queuing discipline, which internally uses a first-in, first-out algorithm. Since an algorithm is doing the traffic classification for us, it's not necessary to mark each connection and packet in many situations. It also means that you can achieve excellent results with just one queue. Let's take a look at how this can be configured. There is no Codel queue type available by default, so it must be created. To do this, when logged in via Winbox, go to Queues, then Queue Type, and create a new one called Codel and set the kind as Codel. You can leave all other settings as default. Next step, go to Queues, General, create a simple queue and specify the relevant target and/or destination as well as a connection speed for upload and download. In this example, we'll only be using the target field, which will affect all traffic going through Ethernet 1 interface. In our test, we used a max up and down limit of 20 megabits per second. Move to the Advanced tab and select Codel as the queue type. Lastly, in the Total tab, select Codel as the total queue type. We use Flint for benchmarking since this tool allowed us to simulate a network under load and visualize how the queue manages the traffic and latency. We compared the default small queue type in graph 1 with Codel queue type in graph 2. We were blown away by the results. It's clear that Codel offers far more stable throughput levels while keeping latency low, even when under heavy loads. We ran an independent ping while running IPERF3 on these two queue types. While saturated, the default small queue suffered from unstable latency and packet loss. When we tested Codel, we found the latency to be the same or better than when the queue was running idle. This makes it ideal for all use cases, but would be particularly useful for real-time applications like voice over IP and video conferencing. We would highly recommend using this type of queue in many situations, but be aware the CPU usage when under full load. Ultimately, we hope you find it helpful and can apply it for a better networking experience. If you have enjoyed the video, please give it a like and consider subscribing to our channel for more content. Let us know what your experience is like with this queue method in the comments below. Thank you so much for watching. I'm Tim from Scoop.